For our final inequalities video, we will talk about something that doesn't come up that often on the GMAT from what I've seen, and I'm actually sort of surprised it doesn't come up more often, but it is still useful to have as a tool in your tool set, and useful to know that you at least can do it in case it does come up, and that is combining inequalities. So you probably know that you can combine equations. And so if I have an equation, x plus y is equal to 2, and x minus y is equal to -3. You probably know that you can combine these two equations, and so I can add these two equations. You can add or subtract them if you want. So I want to add them, and that would give me 2x, and then my y's would cancel out. 2x is equal to -1, and therefore x is equal to -1/2. And then you can then plug that in here. So -1/2 plus 2.5 is equal to 2. You can plug both of these in to make sure they check out for each of your equations. That's one way you can solve for equations when you have two or more of them, is by combining them. And this is actually my preferred method. Usually when I have two equations, I very rarely am doing substitution. I'm almost always combining equations because I find that it's it's both quicker and less prone to math mistakes. What people don't often know, though, is you can do the same thing with inequalities, just with a few more restrictions. And so really the rule I know is that you can always add inequalities as long as their sign is facing the same direction. And so if I have A is greater than B and C is greater than D, sign is facing the same direction here, I can always add these two inequalities to give me A plus C is greater than B plus D. Now, you cannot subtract these guys. And so the rule is you can always add inequalities as long as their sign are facing the same direction. So if A is greater than B, C is greater than D, A plus C is going to be greater than B plus D. Now, you cannot subtract these two inequalities in order to say A minus C is greater than B minus D. So this is legit. This is not. And the reason for this is I sort of think about it in terms of wealth or money. If A has more money than B and C has more money than D, then it should be true that A and C together have more money than B and D together. However, it is not necessarily true that the difference between the amount of money A has and the amount of money C has is greater than the difference between B and D. And that's because you don't necessarily know. It could be true that A is a billionaire. A and B are both super rich, and just happens that A is a billionaire and B is a millionaire. Well, C and D are both dirt poor, but C is a little less poor than D. But it could also be true that A is a millionaire, B is dirt poor, C is a millionaire, and D is just a slightly poorer millionaire. And so because we don't know any of those relative amounts, you can't say this is true. Now, there's a way around this. If I I believe you can subtract inequalities when their sign is facing the opposite direction, but that's confusing to me. So if I ever wanted to, for some reason, subtract two inequalities, what I would do is I would just multiply one by -1 and then add them, because that is the same as if I had subtracted them. So if I have these same two inequalities, I would just multiply this bottom one by -1. And remember, when I multiply this by -1, I now have to flip the sign. So this would give me -c is less than -d. And so if I want to add them, I've got to make sure the signs are facing the same direction. And so now I can add them to say a minus d is greater than b minus c. And this would be true. And this would be the same as if I had subtracted them begin with. So really, when it comes to combining inequalities, this is the only rule to know, because you can always turn a subtraction problem into an addition problem. Let's do a quick problem showing this. If b plus c is less than 3a, is a greater than c? So we are given this inequality here, meaning this is a universal inequality. It applies to both of our statements. And so we can think with, before we even look at each of our statements, we are spotted this inequality here. So b plus c is less than 3a. So if they're asking us, is a greater than c, but really, if they're just asking us about a and c, doesn't even really matter that they're asking is a greater than c. What that means is I want to get rid of this b. And so that is my goal when I'm combining my inequalities. I want my b to cancel out. So statement 1 tells us then b is greater than 2a. So now all I have to do is I got to get my inequalities with their signs facing the same direction. So I'll just rewrite the first one. Oops. As 3a is greater than b plus c. And now I can add these guys. 3a plus b is greater than b plus c plus 2a. Lo and behold, subtract b from each side. My b's cancel out. Subtract 2a from each side. A is greater than c. This answers my question. Sufficient. Statement 2. So this is my universal inequality. And then statement 2 tells me b is greater than 2c. And so I need my signs facing the same direction. So this one I can write the inequality for my statement like this. In order so my inequalities are both facing to the right. Now I can add these now. So b plus 3c is less than 3a plus b. Again, first thing I'm looking for is see if my b's cancel out, which they do. I get 3c is less than 3a divided by 3. A is greater than c, which is the same thing I had in my first statement. So this is also sufficient. D is the answer. And so that is the last thing worth knowing about inequalities. That is it for the inequalities series. Remember, when you're dealing with inequalities, you just need to know two things. When you're multiplying and dividing by a variable, you need to know whether or not it's possible it could be equal to 0. You need to know its sign. If it's positive, then the sign retains the direction. If the variable is less than 0, then when you multiply and divide by it, the sign flips direction. So let's move on to the next series.